Okay, okay, okay. Testing, 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 testing. Brothers and sisters, sisters and brothers. Yo, 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 yo. So, a menace. And in this stream, we'll just grind delete code and we'll do a bunch of things. We'll write a blog, then we'll do some lead code, then we'll do some system design, then we'll study some ML. There's one thing that I like, that is the writing of like the blog thing, but everything else I absolutely hate. I despise, but such is life. In this job market, you don't get to pick uh, what you want to do, you just gotta grind. So, this is today's thumbnail. I just made it like a few seconds ago. Shout out to Excalidraw. What a software, dude. What a software. Great software. So that's the thumbnail. This is the Pinterest board that I got it from. Gotta like this. Bye bye. Oh, hold on. There's different reactions. Good idea. Love. Thanks. Wow. Haha. I'm gonna say wow. This deserves a wow reaction. Oh. Most of them are like, haha. It's okay. Cool. Anyways. Cool, 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 cool. So, this is what we're doing today. This is us. MS Paint. Yeah, this is what you wanna do. This is interesting. Ooh, my god, bro. I kind of like this one. Allow. Ah, this. Wait, where did the. Where did the color palette go? Hold on, hold on, hold on. Oh, nice. Okay, hold on. I see. I see. I did something. No. No. Hold on. Leaving the site. What is this one? This is just bad. This is such a bad canvas, dude. There's just so many ads in here. You. There's just way too many paint apps, right? Interesting. This is not good at all. I think this is a good one. But how did I hide this? I pressed some key. Not this for sure. No. How did I toggle this? Anyways, that's fine. Cool, this is really good. My favorite whiteboard, I would say. Oh. Oh, I did this, okay. Oh my god, this does not work at all, but whatever. I like this. This is like the perfect drawing app, I'm not gonna lie. Yeah, easily the top 10 RTAP. I remember when I was a kid, I used to do something like this. I used to just like make random fucking lines and used to just fill them with like paint. Yeah, bro. This is how I used to do it. Whatever, bro. Anyways, let's start working. Um, can I open lead code? We're gonna go to company, I guess, or I could just go to needcode.io. Just go to needcode. I've done a lot of these, honestly. I just need to update these. Could I do tries, maybe? I've never done tries, so I should perhaps do tries. There's this daily temperature. So here's the deal for the day, right? I'm not gonna set any timer. I'm just gonna, yeah, I'm just gonna use my brain. I'm gonna take as long as it needs, as long as the problem needs to solve, and then I'm just gonna solve it, right? I'm not gonna try to reason with it. I'm not gonna try to. The point for the day is to raise the cognitive ceiling. Today's main point is to, yeah, just keep grinding, I would say. Right? Just keep grinding, I would say. That's the goal for the day. And so there's going to be extreme discomfort that will come with this, right? There's going to be extreme discomfort in just streaming, but fuck it. Fuck it. Discomfort tolerance is what makes a man great, right? So let's see. I'll do greedy questions because I've just not done any greedy questions. I've done most of them. But I need to learn. I need to like collect these patterns. So let's do this first. Actually, hold on. I need to like fix my earphones. This is better. This is like so much better, dude. Okay, cool. Next, let's try. So, given an integer array, find the subarray with the largest sum and return its sum. Okay, subarray. So, what does subarray tell me? So, okay, here is something that I'm gonna say. Okay, so need code 150. Screw need code 150. I'm just gonna go to the very bottom and I'm gonna call this observation skills. These are very important, right? So every word, every like the more problems I solve, the more observations I get. Like the more problems I solve, the more I realize that most problems have a trick, and that trick relies on a subtle observation, right? So random collection of observations that are useful when solving these questions, right? Solving coding questions. Also good phrases to use in interviews in case you are blanking out, right? So here's the thing: when you are talking to an interviewer, you wanna not be silent. You wanna keep saying things. You wanna keep listing out your observations. So I'm gonna be like observations, right? Observations is subarray. The word subarray implies that whenever I am solving a question, it's gonna be a continuous uh, sequence of numbers in this array, right? Cont sequence of numbers in the array. It's going to be a continuous sequence of numbers in this array. So why is that important? why is this observation important? Here's the deal, right? Here's the deal. Since you're dealing with a sub-array thing, uh, hold on, what the fuck am I doing? Screw this. I don't want to show my solution. I want to solve it again from scratch, okay? So, uh, subarray with the largest sum. So it means that I could do this one number or I could do this highlighted sequence, but I cannot do this and then this. I cannot pick -2, 1 and then -5 and 4, for example. Like, it has to be a continuous sequence, right? And why that is important is that gives us some constraints. Like, that gives us some, like, these constraints are usually good. That reveal something about the structure of the problem. Now, what is the simplest way? I want to find the largest subarray. So if I want the largest subarray, I could perhaps look at the most brute force approach. Now, here's the thing. When I'm thinking of the most brute force approach, my brain is still foggy. And I do not like that fog. I know that there is a brute force approach to do this, but it's very inchoate. It's not fully formed. And that is something that I do not like. Like, as soon as I see a problem, I want to know the solution immediately. It should click. It should not be in a state of being inchoate. So here's the thing. Like, if you are trying to approach a problem, if you're trying to solve a problem, there are going to be certain number of steps that you take before you reach to a working solution mentally. This is what I'm talking about. Like, the moment you read a problem, you comprehend a problem, and then reaching its solution is going to take a few steps. You're going to have to reason a little bit. Now, here's what I've seen in my old ways of thinking. When I was young, I used to do random walks when trying to solve a problem. I used to try out different approaches, and that used to fail spectacularly. What I like to do nowadays is really dissect the problem. I really like to reason with the problem. I like to see the problem. Like, I believe that we don't see these problems enough. Like, just reading the problem isn't good enough. Like, I have seen levels of impressions that a problem makes on someone, and it's insane. Like, I've seen geniuses who will read a problem or read some, like, to give you guys an example, I know a person who reads books, and he doesn't just read for meaning, he reads also for grammatical structure. He also reads for the author's moods. He also reads for like the lining with the pages. Like, when he is reading a word, he also tries to capture if some of the words are, like, properly aligned, how many words are, like, well aligned with the words. He also sees like, diagonal and, like, vertical gaps in a text, right? And it just goes on to show that the way you take in input really matters. Like, some people have a deeper level of impression of any problem than anyone else, and I think that is also something that great focus and concentration brings over time. Like, that also kind of, like, reinforces your memory. Like, you look at a problem and it makes such a deep impression in your mind that you don't forget. So, like, for example, when I look at this, I can comprehend this. Like, I can comprehend that, hey, I know that this subarray is I know that functionally, like, the requirement of this problem is that I find a subarray here, but one level of impression that the word subarray has made in my mind is that I know that this observation, this property that I cannot pick numbers in a discontinuous way is going to work to my advantage. That's an additional level of information that I have gathered just by reading the problem. And that, I think, makes a lot of difference. Like, you just have to go through so many examples, so many problems, and then it works out. Like, I think the number of hours is the only key to gain mastery in this. Anyways. fuck all of that. Fuck all of that. Uh, let's get back to the problem. So I know there's a subarray. I want to get rid of this inchoate solution that I have in my mind, that I need to do I need to do like a nested iteration, right? I need to do like n squared iteration to get through this. That's what I think. Like how? So here is the thing. When I say subarrays, a nested iteration, a quadratic iteration can capture all possible subarrays. So if I want to do this, it's just index I to I plus 1. If it's any single element is just index I to I plus 1. Any subarray is index I to j plus 1, or just I to j, for example. And my I should go from just 1 to the length of the entire array L, and j should also go from 1 to the length of entire array. J should actually go from I to the length of the entire array. Bro, what the fuck? I need some way to like quickly. Okay, anyway, sorry. So here's the thing: the brute force solution, right? Continuous sequence of subarray, and O of n square solution will always find all possible subarrays, right? So this is like one of the observations that I have made. So this observation allows me to write my answer in like n squared time. So answer is minus 1e7, for example, just the minimum answer that I can find for L equals, say, len of nums for I in a range of L, for j in range of I and L. Ans equals max sum nums of I, j, and ans, and I'll say return answer. Okay, so here is the thing. This is like a quadratic solution, of course, and I will always try to think of the boundary conditions. So when my I is L minus 1 and j is L minus 1, it's going to be an empty list. So max is still going to work out, but we have covered all cases. So this should work. Right now, here is the thing. I need to train my network. I need to train my mind in essentially figuring out where all I could have gone wrong, right? So first is types. Like type checking is very important. I know L is an integer, range takes an integer, these take an integer, max takes nums, which is an array. This is an integer, this is an integer, answer is also an integer. So this should all work. This is a very simple code anyways, right? So why did this fail, right? This is wild that I failed right away. Like, so this is kind of wild because could it be plus 1? Is this what I was missing? So this is, okay, hold on. This is a ghastly mistake, right? Like not doing plus 1 is a horrible mistake. Like how do you not do this, right? So in case of just 1, I know that my I is gonna go from 0 to 0. This is also gonna go from 0 to 1, right? The length is 1, so 0 to 0. And because it's gonna go from 0 to 0, it's always gonna be just this. So okay, so here's the thing. Why is it that I did not see this coming, right? Why is it that I was so confident that when I evaluated these indexes at the end of the array, I was so confident that it will cover all cases, right? When I say L minus 1 and L minus 1, it's going from L minus 1 to L. So this is L minus 1 and it's currently here, and J is also L minus 1, so it is also currently here. And when I would want it to look at this, it should have, okay, so mistakes in mental models, right? First mistake that I made right now was when I imagined array at I minus 1, L minus 1, at I equals L minus 1 and J equals L minus 1. I imagined the cursor to be after the last element in array. This was wrong, right? So this was wrong, right? So whenever you're doing a two-dimensional looping, it is always advisable, to essentially do a j to j plus 1, right? So cool. So this is one. This is definitely one of the answers. Now this is essentially my first n squared operation. Now I know that a solution to this can also be done with divide and conquer, maybe, right? Like suppose I have look at the left half of the array and then I look at the right half of the array, and the answer is that, right, I look at the left half of the array and the right half of the array, for example, we want the maximum sum, right? We want the maximum sum. It's either that the maximum sum array is going to be something in here, right? It's going to be either something in this, it's going to be a subarray in this one, it's going to be a subarray in the right, or it's going to be a subarray that spans across left and right. That's what we need to figure out, right? So I knew there was a technique called the prefix sum. How would that help here? Would that help here, I wonder? Would that help me make it n log n? What if? Okay, so I know that I cannot sort this because subarray, right? Sorting won't work because subarray. Okay, let's just do this, right? Sorting won't work because subarray would lose its order, lose its order. So this is one observation, right? So we can't sort it, right? So if it's a subarray, now say I have left and the right, which essentially returns me so one subarray with great answer, second subarray, then the only thing that I need to do is the middle subarray, like the array that spans across both of these things, right? How would I do that? So if I know that the maximum sum lies in this one, what does it mean? Okay, so here is a question to ask yourself, right? Suppose this is my array and the subarray, which is this one, right? Right, so this one, what do these dots, so suppose I have my subarray here, right? I've found my subarray, maximum subarray, I've found it, okay? What does it mean about elements to the left and right, right? Like suppose optimal subarray has been found. Optimal subarray has been found. what does it mean about the left and the right side of my array? Then what does it mean? Uh, what does it imply about the left and the right? So I know that it implies including any element from left or right makes it suboptimal. Optimal. I know that if I add -5, takes the value down, and I know I can just add it. I have to add it in sequence. Makes it suboptimal. Anything outside of this makes it suboptimal, right? So I can't include this because it makes it suboptimal. I can't include this because it makes it suboptimal. Now, what about adding one more here? For example, like if I have a bunch of these, if I had a bunch of these questions with me, what does it mean about left and right? I just know that adding them would make them suboptimal, right? Suboptimal. But here is the thing. Here is the thing. I know adding anything from here to this is gonna make it suboptimal. Adding anything from this to this is gonna make it suboptimal. But what about something over here? Like suppose I had something on the right side too. Like I know that my sub answer is gonna add something from this to this. It makes it suboptimal. But what if there was something on this side that if included like this made this array better, right? Right? So I could essentially check if adding elements from the left to this makes it better, or adding elements from the right to this makes it better, right? And then we could see if the solution is optimal, I guess, right? That could be one. Now, how would that iteration look like, right? I'm essentially saying that I'm doing divide and conquer. I'm essentially proposing a divide and conquer solution for this, wherein I am essentially saying that when I do divide and conquer, sorry, just replying to a text, I guess. Okay, my bad. I was just replying to some texts. I should not be randomly breaking into different. Okay, sorry, my bad. Cool. So I know that left and right is something that we have, right? We have a left array, we have right subarray, and we have an optimal answer in between. So we know for a fact that looking anywhere. So okay, hold on. Suppose I have two halves, right? I have this half, and then I have this half, and now I'm looking cross halves. Like, does it make sense to include anything in this? Because I know if I include anything here, right? But what if it is used by this dude? But no, we know that if it were optimal, what does it mean? These are values. There's just one magnitude, right? You add these numbers together, they're gonna grow, or they're not gonna grow, or something of that sort, right? Right? Or something of that sort, right? So this is one, this is one. So that's fine. I'm gonna ignore this. I'm gonna ignore this. I'm just gonna maintain the sum for this, the sum for this, and then whatever elements are here, we need to figure out what to do with these elements, right? That's what we need to do. So how do we combine these elements, right? We need to check if, right? We need to check if what happens, like what is a quick way of saying that, hey, what happens if I add this element to this dude, right? And that's when prefix, sum, or product arrays come into play. So, okay, here's a neat thing about prefix arrays, okay? So there's a prefix array, for example, right? Here's a normal array. Its prefix array is gonna be something like this. So it's 2. 2 minus 1 is minus 1. Minus 1 minus 3 is minus 4. Minus 4 plus 4 is 0. 0 minus 1 is minus 1. Minus 1 and 2 is 1. 1 plus 1 is 2. 2 minus 5 is 3. 3 minus 4 is 1, right? So this is essentially a prefix array. This is like a prefix array that essentially tracks okay, anyways. This is a prefix array, and why use a prefix array, one might ask? One might ask, why use a prefix array at all? Right, baby girl? So one of the advantages of prefix array is, like, so if I want to check the optimality across these two arrays, I can check, suppose I want to check the element k, right? I want to say if k plus all of these work, then I need to simply go to the kth element in the array, right? I go to 2, and I then subtract this from k, right? Because I know k is just the sum of this. So prefix arrays are a great way for me to essentially keep a track of which elements to combine, right? So if I want to combine this with this, I just know I just need to do this minus this prefix array of k minus prefix array of I minus 1, and then boom, right? And then boom, right? That's how I gotta do it. And that is essentially gonna be my sum that I need to entertain. It's either this or this or this or this or something of that sort, right? So here is a divide and conquer approach. So okay, you could use divide and conquer and consider using prefix slash suffix arrays, right? So prefix and suffix arrays are especially good for calculating sums in calculating optimal answer across, okay, while optimal answer while combining my results, right? This is gonna be my prefix array answer. So here is what I will do. Cool, this is all fine. So prefix r is, okay, prefix prefix f for forward is essentially so what is the minimum length? Is just 1, right? So it's just going to be nums of 0 plus nums of I minus 1 plus nums of I for I in range L, right? So what this is going to do is, okay, so prefix m is going to be, no, this is a bad code. This is a bad code, bro. Right, so I'm just going to like prefix right, so it's going to be nums of 0. Or why am I doing something so complicated, right? So prefix f of I, that's all, right? And this is not this, it's just this, right? So, and prefix b is again nums minus 1 times L. So we're gonna do this the backward way as well. So it's gonna be L minus 1 minus 1 minus 1, right? So prefix b's I is prefix b's I plus 1, right? And then you get the suffix and the prefix arrays. Cool. Now I'm going to say def dnc, just divide and conquer. Okay, cool. So I'm going to say like array. That's what it's going to take inside. If len array equals 1, right? This is going to be our base case. If you just find one thing, you have to return array 0. That's going to be the first thing. Then you're going to have to return the start and the end. So st, so 0 and 1. That's what you return, right? The start of the array and the end of the array, I guess. Okay, or what I'm going to do is I say j. I'm thinking, right? I could pass the entire array and I pass in sum of array from I to j, right? And then I say, hey, you know what, return I and j, because that's going to be the answer, right? Then I'm going to be like m equals I plus j, right? L is going to be dnc divide and conquer of my array. You know, I don't need array. I'm just going to be like non-local nums. Okay, so I m r is dnc m plus 1, all right? Say j, for example. And I'm gonna be like, hey, max sum ij. So we need to give just the sum. We don't need to give the array, but just dnc 0 and L, right? So L is going to be L plus 1, so it's always going to be like one index after this. And technically, we just need to do this. I'm just going to comment this out. Technically, we just need to do just max sum is what we need to return. Of course, we need to work on this part. Merge the inputs somehow, right? So how do we merge the inputs, right? We need the prefix f and prefix b as well, right? So L sum L low L high, right? R sum R low R high. These are the three things we get, right? Here is what we say. Here is what we say. Cool. M sum, okay, is -1 E7, for example. We'll just say this, okay? Now, first thing we need to do is for I in, okay, not I, remember I and j come from here, for our m in range of, so we know that this returns the high for my left. So, and this is going to exclude the array, right? It's going to be like last element always excludes it. So we can just say L high from L high. L high is just going to be the mid, right? Okay, so we know from m plus 1 to, from m plus 1 to whatever is R low, right? So write low -1. This is 1. So from this to this, we gotta check max of m sum and max of m sum, and then we know we needed to the forward prefix of m, right, minus forward prefix of L low -1, right? This is 1. In the same vein, hold on. So let's do this, right? We need to capture these also. If greater than m sum, if this is greater than m sum by any chance, if this sum is greater than m sum, we say m sum equals this, and f low is like final low equals f high equals minus 1, for example. Okay, hold on, let's not do this, just be safer, right? So I'm gonna be like, hey, my f low, right, my f low is gonna be L low. F high, on the other hand, is gonna be M, right? This is gonna be my M, right? I kind of see that F low can just be this, right? It can just be this, right? Now, similarly, I'm gonna go the other way around. So I'm gonna go from my M of, so I'm gonna go from M to L high, right? So L high plus, okay, So I know I need to go L high minus 1, right? Because this last is excluded. And then we got to do minus 1, right? And now I'm going to be like prefix B. The backward prefix, I'm going to be like, hey, if the prefix B of M is greater than the prefix B of the prefix B of R high, because R high is anyways going to be just excluded, right? So if I know that this side is going to be higher, so if that is the case, I'm going to be like, hey, you know what? If this is going to be the case, I say that my F low is essentially going to be M, and my F high, on the other hand, is going to be the R high, of course, right? This is what I'm going to do, and I'm going to simply say whatever happens after this, sum of, if I'm going to be like sum of nums of, brother, what the sigma, bro? My bottle fell down, but it's still doing okay. Alright, so if my sum of numbers is greater than, okay, so sum of numbers between my L low to R high greater than M sum is just this sum. This is again a case that we could pick that, you know, honestly it gets automatically picked up, but this is just, no, it doesn't get picked up, my bad. And F low equals L low, F high equals R high, and whoopsie, we return M sum, F low, F high. So this is one way I'm thinking we could work. These are all big O of n at most. So this should take n log n solution, I guess. Again, not the best, but still we could give it a try. I don't even know if I've written the algorithm correctly. The index is out of range, of course. So I know that, oh shit, it should be like this, and nums minus I guess so. I don't know, bro. This is a hard thing to nail in the first go. So it's just recursed too much, I guess. Okay. Hold on. So again, we don't have any time limit, so we're just gonna see what happens, right? We're gonna see where it gets stuck. Of course, it's gonna get maximum recursion depth. So it did this. But we did not handle the empty case. Why would I ever go to empty case, right? It went to 2 and minus 1. It went to 1, it went to 2 and 1. Which honestly makes sense. There's nothing wrong with this, right? Cool. So what is 2 and 2? 0, 1, 2. So 2 से लेके 2 तक. Oh, it's like when you only have a single element. Oh, it should have been like this, I guess. Oh, weird. Cool. So it at least recursed this in the sense that it gave me good partitions. So this was one ghastly mistake. 2 and 1, right? So it failed here. Right, it's just gonna fail here, so I might as well, right? It's just fuck it, real or fuck it, real or fuck it, yo. So I'm just gonna run this shit and I'm gonna see what happens. So -5 or 4, right? And the index is happening on this 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So it's this dude goes from range of M, and then it gets fucked right here because at the very end it says, okay, I'm going from low of 7. So it is 5 and 4. So while combining these two things, it's getting fucked. So it goes from 7 to 8, which is 0, 1, 2, 3, 4, 5, 6, 7. So 7 to 8 is 5. 8 to 9 is this. So prefix B. So forward में कुछ पंगा नहीं है, right? Forward में कुछ पंगा नहीं है. So R high is 8 and prefix high is never going to be 9, right? Prefix B, for example, at the very end case, right? So I could perhaps do something of the sort that I could do. Right, I could just simply do like could be. Right, I could just do this maybe. Or right, I could do this. Because it could otherwise fuck things up, right? Here is the thing though. It works for this. Gives me 23. Does not work for this. What does it give me? The final answer that it gives me is 8, 4 से 9. 0, 1, 2, 3, 4. So 2 plus 1 is 3. This is wrong though. There is no way it can get to 8, right? There's no way it can get to 8 though. Can it? So let's see. Right? It gets to 2 and 1. So it gives minus 2, 0, and 1. And 1, 1, C 2, which is perfect. Right? It gets to 1 from 1, C 2. So just this one thing, again, it's hard, honestly. There's so many mistakes I could have made. So minus 1, and so the problem is there is no way this can be higher, right? Alright, I can essentially go here. I can guarantee that these are right, correct? So these numbers are right. Now if I do print of my prefix b also, right? Here is the thing. I go from M plus 1, so the thing after, I wonder if this is causing the issue. And I know that M could be this. Oh my god. You see, this is a big problem because I'm reusing this element, right? Right? There's a miss, honestly. Let's try to run this again. Could be, of course, could be an issue again. So it still says minus 1 to 2. So I'm thinking if this needed to be this and this needed to be this. Oh my god, bro. This kind of seems right. Alright to me. So minus 102 is the problem, right? It thinks it's minus 102, which is kind of wrong. So my M midpoint is going to be I plus j by 2, whatever that index points to, right? Now I know that my prefix R fix should have worked, right? This should have worked, honestly, right? So I'm just going to do like this first now. Like here is ones, here is ones, right? So just checking. I'm just checking now. Just debugging the very first thing which is going wrong. So minus 10,001. This is the problem, right? The very first thing for this should have been minus 2, right? Because if I say prefix f of m, m starts with whatever is m plus 1, right? Just debugging, bro. Just debugging this shit, bro. We're anyways cooked. We're anyways cooked. So 1 is the midpoint. This is the midpoint, right? And 0 to 1 is this. So when I go from 1 plus 1, it's gonna be 2. To R low, what is my R low? It's 1 minus 1. It's never entering this, right? What is my R low? R low is 1, right? So when I say that go from my M to R low minus 1, I should have known that R low is essentially just going to be my excluded anyway, so I don't need to do R low plus 1. I just can't do R low. Oh, hold on. R low minus 1. Okay, hold on. This is the problem. This loop is working perfectly, honestly. These loops are working perfectly, but when you have only a single element, I never ever so this, I think the logic was right. I just did not do this, I guess, you know. Give me this. This failed again, but this is kind of easier to kind of navigate. So 9 2, this is good for 1 and 7 8. So 7 8 decided that together 15 is going to be better, and then 15 minus 1 decided 15 is still going to be better, right? And when 15 and 9 came together, right, and then this came, right? I'm gonna just do this real quick, like fuck that. Fuck yeah, fuck them, bro. Fuck them, bro. This is gonna be easier to debug, I guess. Cool. So we'll go here, I guess, and we'll go here real quick. So now what we are doing is we're at this stage. We got 9, 0 to 2, right? From 0 to 2, 0, 1, 2. So this is excluded. We got 9, and from 2 to minus 1, this is 2 to minus 1, just this. I see. I don't know, I'm just trying things out, bro. Okay, anyways, let's go debug this part. So 9 goes to 0 to 2, 15 goes to 2, minus 1, 3. This is kind of wrong, right? So 15 should have gone from 2, 0, 1, 2. This is kind of wrong though, right? So 9 is good because it's coming from 0 to 0, 1, 2. Actually, yeah, this is kind of right. But this thing should have been 3 to 4 to 5. Right, this should have been 3 to 4 to 5. That's the problem, right? So let's see. 3 to 4, 4 to 5, right? Now 15, 4, 5 is perfect, right? 4 and 5, this is perfect. Now when I do these two things, right? When I combine -1, which is 2 to 3, and 15, which is 4 to 5, it gives me 15. I see now. Okay. Kind of get it. Silly mistake, honestly. So we know this works now. We're going to do this. This is the only thing that gets fucked now, right? It's a harder question. Not a harder question, it's just getting it in n log n is a bit hard. That's the only difference. That's the only problem we have here. So we've got this in n log n right now. Not log n, it's n log n. We want to see if we can do this in log n. But anyways, we just got to do it in n log n, I guess. It's a bit complicated, I guess. Why am I not getting it right? Right? It's a problematic situation that we are in right now. Right? We shouldn't be taking this long to code something so simple. But we are taking so long. Nonetheless. Right? Fuck it. Fuck it, bro. Ooh. Okay, I guess. Real or a fuck. Anyways. So you just gotta sit through these. You gotta debug these questions yourself and figure out why you are going wrong, right? I'm just trying to figure out why I'm going wrong. Right, so it has been an hour. Just been an hour. Just been a little bit over an hour. A little bit tired, I would say. Screw this, brother. Screw this. Yeah, am I hungry? I'm very hungry, honestly. But that's life, bro. करना तो पड़ेगा दोस्त, पढ़ना तो पड़ेगा, पढ़ना तो पड़ेगा. I need to get this to work though, right? And the thing is, this is such a complex question. The log is so complex that we just gotta do this. So is the combination right? Its combination is right, it just goes from 1 to 2, which is perfect, right? So 3 to 4 is the combination, right? It's 3 to 4 is 0, 1, 2, 3. So 3 to 4 is perfect. This works perfectly, right? So I'm just gonna like note these things down, right? So okay, this is good. So far till 3 to 4 we're good, right? Now we get 4 is the greater one, 1 is the greater one, so now we get to uh, right, so this is good. So 3 4 and 3 and 4 is good, they're well decomposed and shit. So the leaves have been decomposed really well so far. This gave us 3 and 4, and now in this entire thing we get 4, which is the max of array, which is 3 to 4, right, which is perfect. Now on the second half we get division minus 1 and 2, which is 2 5 6, so 0 1 2 3 4 5 to 6, which is perfect, and 1 5 4, so we get 4, it just gets 4 here, this is just 4, right, this just gets us to 4. I think I've done something messed up in the combination. So I see 154 is just decomposes to 1, and 54. 54 says 4. I return with 4. 489, which is like perfect, which is what we wanted, right? 489, which is perfect. Now we get to this combination of 1, 5 and 4, so it's like 1, it says 1, which is 6 7, so 1 2 3 4 5 6, 0 1 2 3 4 5 6, so this is 1 6 7, and then there is 4, which is 8 9, which is this, which is correct I guess. So 7 to 9 is what it's thinking. This is where it's going wrong. Right? Why is it going wrong here, right? So I have these arrays, right? I have 4 going from 8 9. This is 7, my mid is 7. 0 1 2 3 4 5 6, 0 1 2 3 4 5 6 7, this is 7th, so my mid is 7, right? So there should have been someone who tried, if my mid is 7 and my optimal is 1 and this is 4, so I essentially need to try 1 plus something beyond 4. Did I try that? Alright, so I did this. Then I did, after this loop was completed, it said 4 8 and 9 was my answer. 4 8 and 9, which is perfect. It said, hey, sure. I didn't find anything. So it's 7, right? 7 plus 1 is 8. 8 to row low is 9. 8 to 8, so this was an empty loop. It said, hey, you know what, there's nothing here, there's nothing in between this space, so fuck this, and said that's it, right? So my second m is just 9, right? Second m is what is m is m plus 1 was 8, right? So it did 8 to 8 and didn't do 9. So this one was 7, this is just this 7, right? And L high essentially went from, L high was 7, so it went from 7 to 7. This loop exited, which is weird. This loop didn't exit. Hold on. So m is 7, that I know for sure. M is 7. My L high is 7 minus 1 6. 7 minus 1 6. So 7 6. And this is something where weird thing is happening. So prefix fab of m, which is 6 1, minus prefix fab of r high is 9, b 0, R high is 9, 0. So 6 minus 0. Oh, sorry, 1 minus 0 is greater than m sub? No, it's not. But it's for some reason it's saying that, hey, I'm getting something of this sort. This is kind of getting weird, right? So m can only be 6 here because it's going from 6 to 1. So a prefix b of 6. 0, 1, 2, 3, 4, 5, 6. This is 6. Right? This is my 6. And is 6 minus of 0 r high. This. Is this greater than m sum? Well, it kind of is, but I think L high should not have been minus 1. I feel this. I'm just going to try this. I think this one was the issue, like L high should not have been minus 1 maybe. And I'm pretty sure this is not going to be the perfect answer because it's just going to keep failing somewhere. Again, it's just so hard to debug these like divide and conquer questions because, you think you got all the edge cases, but you pretty much don't. I'm pretty sure when I submit this, it's gonna cause me some issues somewhere, right? So this is gonna be my n log n solution, which I came up with divide and conquer. If I try to submit this, we'll see what happens, right? The output is 6, and okay, anyways, I'm not gonna be bothered to debug this. It's need 196, 14 more cases to clear this. Do I have the patience to clear this? No, I do not. The question now is, we went through greedy, so the answer should be somewhat greedy, right? Sure, this is like an n log n answer, somewhat n log n answer, right? And these things I think I just need to keep in mind, right? Like a template for n log n, right? I think I need to like whatever, I could perhaps commit these to my memory or something. I don't know. Anyways, nobody's going to run these for me, right? Okay, cool. Anyway, so I know that I did a lot of debugging, and I know that in order to get these questions right, I'm just gonna have to like, this part I got kind of wrong. This L high thing I got wrong, I think, but most of these things I got right in general. But now let's try to see if there is something that we can do in greedy time. Greedy, right? Here is what I think we can do. What if I create a prefix array like this, like so, right? I create a prefix array like so. Now, what is it that I get from this prefix array, right? If I want to find the maximum subarray till a point A, right? Suppose this is the point A that I have. What is the maximum subarray till this 1? Can I frame the question like this? I want to do greedy, right? Greedy means that every iteration pick the next best option, right? Pick the next best option. How does that make something greedy, right? So I could say that, hey, you know what? If the next element is gonna increase the size, say I say the size of my array is just -2. If the adding next element, if it's gonna increase the maximum sum, select it, add it to my subarray. If the next element is gonna increase the sum, add it. Otherwise, you decrement the, So next best sum you already know is 1 so far, right? So okay, 1. So I added to 1 2, right? For the next element I said, hey, does adding this improve things? I could be like, hey, I still have 1, right? I could just look at the current element as well. Right, so if not, I'll just select this one. The next element I check, I say, hey, are you increasing my value? No. And check it standalone, are you increasing my value? I said no. Okay, I'm like, okay, I'll go to the next element. I say, hey, are you increasing my value? No, but this does not seem greedy enough to me. Right, I'm just gonna go through submissions. I'm gonna see the accepted submission for my greedy one. So for any nums, for the sum we just add 1. So if the current sum is greater than, you do this. Otherwise, if it's less than 0, you make it 0. So there's a subtle observation going on here. Right, there's a subtle observation going on over here. Oh my god, bro. Okay, I get it. Cool, I get it. I get it that what I get from this is that, okay, now that I'm working with this subarray, right, what is this observation that we are making? It's a good observation, right? What question did I forget to ask that would have allowed me to get to this solution, right? What question could I have asked myself that would have allowed me to reach this solution? That's what we're going to try to figure out, right? Okay, so here's the thing. I'm not playing around enough with these questions, not playing around enough with the numbers, right? What all do I know? One observation that I do know for sure is that this is going to be a continuous array. Second, I know I can't sort it. Third, I know that there are negative numbers, right? That also is a trick. Like, if you see the negative number in your array, then it means that if you only had positive numbers, you knew the sum of everything was your answer, right? Now, would it be fair to say that the window with the largest positive numbers was your answer, right? Does it make sense to ever add any negative number? Because negative numbers will always decrease your product, decrease your sum, right? Okay. So this is another good observation. Mix of positive and negative numbers. So this is a good observation because I kind of see now that it's so subtle, so simple, right? The reason why I can do greedy so these are good notes, honestly. Mix of positive and negative numbers. This implies that if the largest continuous span of positive numbers is gonna be the local optimal solution, adding any negative number to it is futile. In fact, in what it could mean, what I missed, right? I could have gone further and asked myself, uh, what makes it suboptimal? What values make it optimal? Right? So this was an important question that I could have asked myself. So anyways, I get it now. So I'm gonna go back here. I'm not gonna look at this. So I know that current sum. Okay, so max sum, current sum minus 1e8 maybe. Current sum for n in nums. C sum plus equals n. If C sum greater than m sum, C sum. If C sum less than 0, right? If I ever see that there is anything that is decreasing to making it negative, that's the thing that makes it suboptimal. Right? I'm like, fuck it. I'm like, m sum. Right? I don't know. Of course, this could not be the best answer, but I want to compare this now. So if that's it. Such a good question, such a good analysis, honestly. Such great meditation on this question. Right? Yeah, whatever. We'll just paste this here and then, okay, what happens if I paste this like this here, right? Yeah, whatever, bro. Whatever, bro. It's hard because you just gotta have to you gotta build these observation skills, like these are important questions. So I'm gonna blur my vision real quick. Okay, beautiful. So we have already seen this, right? So you're given an integer array nums. You're initially positioned at an array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or false otherwise. So now we want to do this greedily. Right, these are jump games, right? This is no sub-array question. There is no sub-arraying that we need to do. We just need to do traversals, some sort of traversals, right? Each number represents the maximum step that you can take, right? And you can either start at 0 or either start at array's first step, right? Jump one step from 0 to 1 and 3 to last step. So 2 is what? So what if I just go with greedy, right? What if I just go with greedy? I could always start with greedy. Okay, first, what makes you think this is greedy, right? Like, why? When I look at this array, for example, and I know that I need to reach the very end position, why would greedy be one solution that comes to my mind? Why is greedy one approach to solve this problem, right? Can I prove that greedy is a valid solution that can take me to the end, right? This is like reasoning 101. What does greedy mean? Just picking the best step. Now the question is, what if you pick a step size that is larger than your destination, right? Then you are initially positioned each element maximum jump length. So it's the maximum jump length. You can take smaller jumps, I believe, right? But that's your maximum jump length. So even if you were at a position which ended up with jump size of something greater, you're fine. You're okay. You could reach, right? You don't want to exactly reach your position, you just want to reach as far as possible, right? Now, one might ask, what if your greedy choice lets you do a maximum jump only at some sub maximum thing? What can you do then? Like, if I jumped from a current step uh, to another step and it's like zero, right? It can be zero for sure. It can be zero. Like, hey, you can't jump no more. You can't jump no more after this, right? You'll arrive at index 3 no matter what. If you arrive at 0, it means that, hey, I cannot reach my last step. Now the question is, could you have done something else? Could you have done something to avoid that step? Suppose there is a step that could have somehow allowed you to reach the last step. Say last step is just something, right? Suppose there was a 2 right here, which could have let you do 2 steps and you reach the end, right? Now the question is, you decided to pick 3 instead of just picking 2. So if I do construction where I have like 1, 0, 2, 3, I still reach the end, right? So if I have n steps to reach some goal or some destination, right? If I have some n steps that can take me through the destination, and say the kth step that was somehow optimal, that I argued was the best step, landed me into a pit, which is 0. It's like, hey, I landed you into pit 0. And say there was a better optimal path which went through, say, n minus 1. Why not, right? Say it went to k minus 1, right? We are saying that k would have allowed me to land on some position, say, between this, right? So suppose the distance between this number and this number would have been like greater, something of that sort, right? Greed, bacha, greed, macha. Greed, bro, greed. We have to figure out which is the greedy option. I pick a step k. My step k is promising me that it will take me to, it's gonna land me on a 0 step. Say there is step k minus 1, which is kind of shorter, but it lands me on b, which exactly covers the remaining distance, right? And say n minus k and b minus n minus 1 is smaller than n minus k. That's fine. The question that I have is why? What is the guarantee, right? If I keep picking them, and the thing is, okay, n and n, right? This question implies, why did I never choose something optimal? Like, why did I arrive at n and not n minus 1 then? Then it means that my algorithm kind of had that sort of condition wherein it says, okay, if you arrived at n minus k, if you arrived at k minus 1, you would have had to do, you chose to go to the furthest step possible, right? But okay, my picking criteria is not correct. So like between 2 and 1, I pick the highest step. For example, I pick 3, right? I pick 3 and I directly go to the last step. I pick between 3 and 2, I pick 3 because it's larger. I go to 0, I don't have anything to do. I say false. Right, that's the problem. Can't do this. What is dynamic programming doing here, right? I know I can solve this with dynamic programming, wherein I can say that in like n time, when I can say like, okay, I look not just at 2, but I look at 3 as well, and I look at my solution for 1 plus 2. I know I can solve it with dynamic programming, but I want to figure out if I can do this with just greedy. Like, do I have proof for my greed? I'm tempted to look at the solution, but that's not right. That's not gonna be the thing. Like, what is another simple thing that I'm missing, right? I'm probably missing some representation, right? Like, I know these numbers are gonna keep adding, keep adding, keep adding, right? So I don't know the future numbers. I just know the current numbers, right? So say I go to 2 and 3, I check 3, then it means that I'm not even using n time to reach my end, right? This kind of means that I'm using less than n just by picking whatever is the fastest. But greedy means that, does greedy mean fastest? Does greedy mean n? Probably not. Probably not. Baby, what's on the other side of this shit, bro? What's on the other side of this shit? Okay, sorry. Okay, we gotta figure this out. I know I can do this with greedy, right? I know I can do this. Sorry, I know I can do this with DP, right? How would you do this with DP, for example? Alright, if I were to look at this, so if I were to look at like jump from step 1, index 0 to 1, then 3 steps to last, whatever, bro. I could have also done this with some backtracking, bitch. Like I try with 2, I try with 3, I try with the 2. Interesting. Here is another observation that I have made. I only have 2 options to start. I have 2 as an option to start. I have 3 as an option to start, right? Right, so if I start with 2, you're initially positioned at the array's first index. Oh, I get it now. So I'm at 2, so my max is 2. So I just take 1 and go here, right? So this one says that I go through all my options, like from 2, I check, I can go here and here, 1 and 3. So I pick 3, for example, right? I pick 3, for example. 3 says, hey, I pick whatever is the max in this, goes to 4, already the last index. So 3 says, hey, in these 3, I pick the max, 2. 2 says I'll pick the max, 0, 1, 0, right? That's the thing. That even if it is like trying to do something, so we know how to do this manually, right? Now the question that we should be asking ourselves is, if I know Sorry, I'm just fidgeting right now. Trying to fidget at least. What I'm gonna do is to celebrate the end of this Sankalpa. I'm gonna stay up a little late tonight. I'm gonna stay up a little late tonight. Pikachu. Sorry, what the fuck am I doing, bro? What the fuck am I doing, daddy? The fuck am I doing? What the frick am I doing? Oh my god, that's crazy. Okay, sorry. Cool. So, how does one make it to the very end, brother? How does one make it to the very end? So 3, 2, 1, right? If I go to 3, till the end of 3 is a cycle. I will be picking the greatest and the latest. So 2 goes to 3 and 1. Now when 3 starts, right? So for example, when 3 goes to 0, does it have to go to 2, 1, and 3? Okay, so 2, 3, 1, 1, 4, right? So when 2, I have 2 steps to take. I can go to 3, I can go to 1. But I have to see my options. I have to take a look at those 2 options, right? The claim of greedy would be that just picking 3 gets you this original end, right? Always picking the greatest one. Always picking the greatest one. Always picking the greatest one. Always. 2 is going to. So 3 takes me 3 and 1. So 3, right? So I've now seen 1. Should I have to go through 1, 3 is 4? No, that's not quite right. Right? 0, 1, 2, 3. So I can be like, bro, listen. Bro. Whoa. Hey, I know how to solve this. I just don't want to know. I know they ask a greedy. I know they say greedy, but I just want to know if you do greedy faster. Right, I know it's Amazon. Shut the fuck up. I know it's Amazon, bro. Oh, somebody gave something. Ah, okay, I like this. I like this intuition. So 4, right? You can start counting from the behind. You can see 0, 1. So it's like 1. So this is going to be like 0. It's going to be like 1, now 2, now 3, now 4, now, oh my god, ouchie. And it gets pooped. 1, 2, 0, 1, 2, 3. If this step matches, if 3 matches, you set index again to 0, 0, 0, 0, 0, 0, 0, 0. Right, they do 1. So it's not just that I want to see if this number here, if it was greater than that index number, greater than that index number, I would keep doing it, you know. Goal change is a change. And what happened to the very boundary condition? Where you're already existing. So, what was I blind to? Does iteration only have to be forward? The iteration could also be backward, as pointed out rightly by my kind friends. Goal. Can I jump? Can I jump? ठीक है. Oh dear, Rupesh. काका तो है ना end. So you're already at the end. Now, if your goal is not 0, you can simply do 0. If nums of goal अगर नंबर इक्वल गोल हो गया, नंबर इज इक्वल टू गोल, then what happens? ठीक है. टर्न इक्वल ठीक हो गया. 0 goal minus equals 1, right? So I have 4. अब स्टडी तो हुआ है. So can I reach this? Can I reach this? Okay. I wanna see the solution, bro. 2023, that was a year ago that I saw this, bro. Cool, so I get this. Kinda get it. So I in range of nums. अगर करंट ज़ीरो हुआ तो रिटर्न फॉल्स कि तुम ज़ीरो पे आए तो कहीं नहीं जा पाओगे, राइट? तब तक तुम्हारा करंट को थोड़ा नेगेटिव में एक डिडक्ट कर लो आपका, ठीक है? मैं नंबर ऑफ स्टेप्स है आपके पास, तो करंट करो या फिर Bro, this was so elegant, bro. Cur equals numbers of 0. Oh my god. Oh my god. Cur minus equals F. Cur. So 2 है मेरे पास, 2 steps है maximum, right? तो कभी ना कभी ज़ीरो आएगा ही. दिस इज नॉट द पॉइंट. तुम्हारा ज़ीरो हो गया, तुम्हारी बस क्षमता खत्म हो गई चलने की, तो तुम भागती ना. Okay, I'm kind of tired. Think I could take like a break real quick and come back. Then maybe solve this again. I don't know. Maybe. 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 Okay, so thinking. Thinking. Cool. So current is numbers. Fine. Man, this is torturous. Could perhaps take a break. I now have to push myself harder and harder and harder. Anyways, let's think. What was the issue here? I started with 0th and I iterated through all the ends. And I kept decrementing current by 1, and then whatever is the max of current versus keep replenishing it. It's like fuel. Like I have the fuel to reach here. The middle part doesn't matter, I guess. I keep collecting fuel essentially. I come here, I got fuel, yay! I come here, I can collect fuel, yay! Murder is the max, right? Tune, hey. You got allowed to collect fuel only when it's smaller. But when you come here and if fuel runs out, no. I get it. Cool. Now if whatever, bro. What the sigma, bro? What the sigma, daddy? Bruh. Brother, if then nums equals 1, then true. We know that. Whatever, bro. That was kind of shitty code. Honestly, bacha. What did I get wrong? I could not think of. Hold on. How did I get it slow? Why did I get it wrong though? I'm doing something wrong here for sure. I was doing something wrong, right? Or what was it? What was it? Yeah. Thinking. Cool, I need like a short break now. I'm gonna keep this on. Let's just do some fun stuff. Again, you need to prove your reasoning by quite a lot. What is $11? Why did I spend $11 at Publix yesterday? It's crazy, bro. That's mad. That's mad, mate. That's mad. Okay, that's cool. I need to figure this out. I gotta do this better, I guess. It's nothing. I've just not even done anything today. I love my thumbnail, bro. Who is my one subscriber? I wanna see. How do I see my subscribers, bro? He doing lead code hard. He doing lead code hard, bro. You know what, mate? You know what, mate? What if I go to X.com? Is there something fun happening here? Baby girls, is there anything fun happening here? Ooh. Ooh, we go crazy. What's on my feed? Let's see. Good. Hmm. Funny, funny man. Okay. Okay, sure. Oh my god. Chun Chunair, oh my god, bro. Amma Achan Chachis Chattans are all and all the loud ones. Molusti badly miss you. Okay, cool. Man, just blocking this. Why are people so butthurt all the time? Block bloody media. Fucking stupid people. That's not a news, bro. And people fucking live. If you made it this far, you're already probably at least semi-interested in this being your career. So I wanted to chat about it because if you're ambitious and want to dedicate your life to work, you pick the best company in America to do it at. I really don't care to hold a bunch of money and deeply believe in rewarding people. Okay, it's alright if we have two teams. We grow to four in the next year, possibly eight in the next two, but I can't talk about that because James will kill me. Haha. Okay. Oh, come on, dude. We need more leaders in the company. We need hardworking, obsessive, coachable, intelligent grinders that can step up and take some of these leadership spots over the next 2 years. Fine. Okay, cool. Suck and how you can become better. Seriously, he will give you a list of things that you need to improve to become what we need. If you actually listen and master those things, he'll give you a shot at the roof. Fuck off, man. There's too much to read. Maybe that's my problem. One or two iterations for improvement ability. Nice, that's so cool. Okay, as a third experiment asked the new model to begin the task in formalizing results in real, breaking it up into sublemmas, which it would formalize a statement of but not the proof. Promising. Okay, sure. So this discussion, I'm considering one specific metric, namely the extent that an assistant can help with our most abstract or complex mathematical research project directly by an mathematician. A competent graduate student can make contributions to such a project that are more valuable than the net effort put in to get such student up to speed on such a project and then supervise their performance. But with the latest tools, the effort put in to get the models to produce output is. However, I see no reason to prevent this ratio from falling below 1x, which I think could be a tipping point for broader adoption of these tools in my field. Okay, I should stress that I should stress that I'm using undergraduate students here as the convenient unit of comparison for this one type of assistant. Totally, we train graduate students primarily to create the next set of next generation independent researchers. They can assist with one's current research, but this should be the purpose of the real world. Okay, cool. So certainly do not intend to imply a one-to-one correspondence between aspect of. Okay, sure. I believe that the marginal cost. Sure, bro. Pretty good. I love this. She stole it from someone. Oh my god, bro. That's good, very good. Mediocrity magnates. Shut the fuck up. Grab it on, bro. What the fuck, bro? Graviton paying 93 to freshes is wild. These drones are low-key crazy, bro. Okay. Crazy Thursday, what are they doing, bro? Open wide, okay. Engineering tech lead for quant founding. Okay, cool. I love this. Hold on.
I mean, that sounds completely made up. They're spending a lot of time and a lot of money begging Jensen, we're building data centers. I mean, my God, we're building nuclear reactors. Are you kidding me? That sounds completely made up. But it's not. You need a lot of power to power acres of these GPU. I mean, it's acres of these GPU clusters. I'm not sure. Has anything like this ever happened before? You know what basic stakes is? You know what it costs to build a frontier model? Anyone know over the next three years? How much will be spent if you want to? You're one of the companies that want to build a frontier model. You know, how much will you spend? Anybody? Anyone want to guess? 10 billion? Anyone? 100 billion? Yeah, 100 billion. That's going to get you in the game. Put down your 100 billion. You ever see Molly's Game? You come in, you say, here's my money. It's not Molly's Game. It's a bigger game. Put in your 100 billion, and you're in the race.
Crazy, dude. Hold on. You gotta send this to a
They're
friend.
spending a lot of time and a lot of money begging Jensen.
Nuclear
We're building
reactors.
data centers. I mean,
Interesting.
my God, we're building nuclear reactors. Are you kidding me? That sounds completely made up. But it's not. You need a lot of power to power acres of these GPU. I mean, it's acres of these GPU clusters. I'm not sure. Has anything like this ever happened before? You know what basic stakes is? You know what it costs to build a frontier model? Anyone know over the next three years? How much will be spent if you want to? You're one of the companies that want to build a frontier model. How much will you spend? Anybody? Anyone want to guess? 10 billion? Anyone? 100 billion? Yeah, 100 billion. That's going to get you in the game. Put down your 100 billion. You ever see Molly's Game? You come in, you say, here's my money. It's not Molly's Game. It's a bigger game. Put in your 100 billion, and you're in the race.
You know what? The next time Adani dips, I'm fucking buying Adani, bro. Hold the fuck on, bro. Motherfucker. Holy shit, I gotta get this shit printed, bro. Hold on, I gotta take a screenshot for this shit. Taking a screenshot real quick. I'm gonna be like documents maybe. Crazy, bro. But
They're
okay.
spending a lot of time and a lot of money begging Jensen.
Okay, that's also something very weird. That also sounds very weird. Holy fuck. Hold on. Hold the fuck on, dude. Hold on. Let's see. Motherfucker, man. I need to up my reasoning skills. There is no other fucking way out of this. Fucking hell, bro. I get it now. Observations and reasoning skills, they have to go up. Helion energy, right? Let's see. Okay, allow all, sure. So they need a fusion power plant. They need a power plant because fusion is what's gonna ensure that you can power all these GPU clusters. You need AI in order to advance this fucking human civilization. You need AI, right? Fucking hell, I get it now. I get it now. You see, a man is not strong enough to work only for himself. He has to have a purpose higher than himself in order to like thrive, in order to like get anywhere, you know. Fucking hell, bro. This is crazy. Hold on, hold on, hold on. We got to do some research on what we are gonna get into, you know. Fuck, bro. Motherfucker. Motherfucker. You know, the genius of Ilya Sutskever is that he made a very simple observation. A very simple observation, which was every thought that you have, you're not aware of the complete thought in the first go. You say a word and then you become aware of the next word. You keep saying words after words. Your brain is essentially predicting the next token. However, we have this ability to reason, and I believe Oven Preview is low-key there. It's pretty much reaching there now. Its reasoning abilities are really good, bro. They're gonna get it. I think they're gonna figure out AI real quick. 100 billion for a frontier model? That's wild, dude. Fuck. There is no one doing services at all. There is no one writing any services. Okay, let's hold on. Let's make an index, right? Let's make an index, right? Can I do some like notes or something here? Hold on, this should be like something to do with notes, right? Notes. Notes for edge. Just notes. Notes. Yeah, it's just sticky notes app, I guess. I may be into this. This may be a good one. Okay, so let's keep a track of ad extension, sure. Now downloads, just go to downloads. Okay, save. Okay. How do I use this extension now? fuck you. Fuck you. I ain't doing this shit. Sorry. Now it's... Yeah, remove this bitch. Yeah, report abuse. Fuck you. I will not do something this evil to you. Sorry, I'm just kidding. But you're just annoying, bro. Okay, hold on. Some things that we need to address first. This is an important tweet, right? It's obvious, Loki, that okay, hold on. It's low-key obvious to us, to me, to us, to everybody over here. That is. Holy fuck, I think the next thing that OpenAI could do is this invention of new tokens. I think currently OpenAI just knows that, hey, you know what, use these tokens and have fun. But I think the next step would be probably inventing new tokens, you know? Like, they're just gonna probably, like, do new tokens. Okay, quick question. Okay, let's focus. First of all, Larry Ellison does not look 80.
We're building data centers. I mean, my God, we're building nuclear reactors. Are you kidding me? That sounds completely made up, but it's not. You need a lot of power to power. They're spending a lot of time and a lot of money begging Jensen. We're building data centers. I mean, my God, we're building nuclear reactors. Are you kidding me? That sounds completely made up, but it's not. You need a lot of power to power acres of these GPU. I mean, it's acres of these GPU clusters.
Fucking hell, bro.
I'm not sure. Has anything like this ever happened before? You know what basic stakes is? You know what it costs to build a frontier model? Anyone know over the next three years? How much will be spent if you want to? You're one of the companies that want to build a frontier model. You know how much will you spend? Anybody? Anyone want to guess? 10 billion? Anyone? 100 billion? Yeah, 100 billion. That's going to get you in the game. Put down your 100 billion. You ever see Molly's Game? You come in and you say, here's my money. Yeah, it's not Molly's Game. It's a bigger game. Put in your 100 billion and you're in the race.
Interesting.
They're spending.
Hold on. How much did ChatGPT-4 cost to train? It's 100 million, that's it? Okay. How much did ChatGPT-5 cost to train? Ooh. According to HSBC, it could be like 1.7. Ooh. Interesting. 6? Motherfucker, bro. Okay, so $40,000 for GPT to fair. That meh. 4 million for 3. 100 fucking million for GPT-4. And it took almost 1.25 billion to 2.2 billion for GPT fucking 5, bro. That's wild. So is it that this did 10x it? And is it gonna get to 10 billion? Shit, compute cost is increasing that high.
A lot of time and a lot of money begging Jensen. We're building data centers. I mean, my God, we're building nuclear reactors. Are you kidding me? That sounds completely made up, but it's not. You need a lot of power to power acres of these it's acres of these GPU clusters. I'm not sure. Has anything like this ever happened before? You know what basic stakes is? You know what it costs to build a frontier model? Anyone know over the next three years? How much will be spent if you want to? You're one of the companies that want to build a frontier model. You know, how much will you spend? Anybody? Anyone want to guess? 10 billion? Anyone? 100 billion? Yeah, 100 billion. That's going to get you in the game. Put down your 100 billion. You ever see Molly's Game? You know, you come in and you say, here's my money. Okay. It's not Molly's Game. It's a bigger game. Put in your 100 billion.
Okay. Sure. I agree. There is no way he looks this good at 80, right? Interesting. Yeah, the problem with Extrapic is that their guy is a grifter. There's an applied physicist who gets like 100, 300. Oh, so it's a good time for physicists now because you could essentially. Interesting. Let's see this.
Physics-based computing, which is thermodynamic.
Let's see.
Our last talk in this session will be from Guillaume Verdon. Thank you so much, Guillaume. How's everyone doing? Good. Ready for some physics-based AI? You heard a lot about quantum, which used to be my world, but there's been a vibe shift towards a different kind of physics-based computing, which is
this guy's a grifter on
thermodynamic.
Fuck him. I mean,
so we're going to be talking about thermodynamic computing today and what we're building at Extrapic. Do you want to tweak it a bit?
I see founder of TensorFlow Quantum, founding of TensorFlow Quantum. Okay, whatever.
Yeah. Cool. Trevor and I started, we brought AI to quantum computing. We basically invented how to bring differentiable programming to quantum computers when we were kids, hacking in Waterloo, a very good university. We basically got absorbed by Alphabet and launched a product known today as TensorFlow Quantum. And we figured out how to bring software to quantum computers. After shipping that at Google Quantum, I ended up starting a team working for Sergey Brin working on quantum telecom, quantum sensors, and quantum machine learning. And Trevor ended up working at Google Quantum in hardware. Through our career in quantum hardware, we realized noise was the bane of our existence. And so we decided to switch sides. If you can't beat them, join them. So bring the noise to physics-based computing. A lot of our team comes from big tech, a lot of major players in quantum computing and ML. All right, so as we all know, generative AI is eating the world. Generative models are getting bigger and bigger. You don't see it super well here, but AI compute demand is scaling exponentially, much faster than Moore's Law ever did, even at its peak velocity. From a software algorithms perspective, it seems the more data you throw at a problem, the more parameters, the more flaps you throw at a model, the better compression code you learn, and the better performance you get. So there's no real upper bound to how much appetite for compute there will be for AI. It doesn't seem to be like it. And so what's the bottleneck to scaling? Where there's a soft ceiling right now where energy efficiency is a big problem, right? Training these models is getting exponentially more costly. This is like CO2 equivalent. This is just GPT-3. It's kept going since then. They're training GPT-5 probably with a nuclear reactor, people are going to great lengths proposing building nuclear fusion to power supercomputers to build computers to train AI. So something has to change, right? That doesn't scale. It's not practical. Why is that? This is a plot from Michael Frank, you're familiar with. Michael Frank predicts as well, like mid-2030s, early 2030s, digital computing is coming to an end. Basically, transistors become stochastic. When you go too low power, you make them too small, right? So they fire sometimes. So your computer becomes probabilistic, which is a very big problem if you have a digital deterministic computer. So you need a fundamentally new architecture, a new way to embed algorithms into the physics of the hardware. You don't have a choice but to go stochastic, and so we call it Moore's Law. And we think we're going to start really feeling it by the end of the decade. And where does Moore's Law come from? Again, it's because transistors are made of matter, and matter is jiggling about, right? And it turns out that you can use that sort of a few hundred times. Our thesis is that the brain is more or less a thermodynamic computer, and the brain has 100 trillion parameters running on 20 watts. So 100 million times more energy efficient and denser than GPU clouds. So it's not totally unfounded for there to be a huge physics-based overhang for better AI compute, right? Like the fact that GPUs are good at AI was a stroke of luck to some extent. And so we want to take inspiration from nature. We want to take inspiration from biology. There's been a lot of efforts in neuromorphic computing, but neuromorphic computing is kind of like being obsessed with biomimicry for its own sake. It's like building an airplane that flaps its wings. It doesn't make any sense, right? What you want to do is you want to understand what physical principle nature has figured out how to harness, right? So you want to understand the principle of lift, and then you make an artificial device that achieves flight, like the Wright brothers. And so that's what we're doing with a different kind of physics than what you've heard about today. You've heard a lot about quantum, which is the physics of the very small or the very cold over short time scales, so things are in superpositions. The physics of the very big or high power is deterministic, so you don't have any sort of uncertainty about the state of the device. But what we're building is algorithm degree of freedom state is this computer to do probabilistic from the algorithmic standpoint. Algorithms, ultimately all generative AI is representing things with your data, right? You're morphing or a probability distribution in your computer and morph it into the shape of your data time. That's complex. And they're not as parameter efficient because, like I said, as the complexity grows, you need more and more parameters. If you want to do probabilistic algorithms on a digital computer, you're kind of screwed. I mean, a lot of people on Wall Street do these algorithms are trying to have it operate slow. So the hardware does probabilistic inference and learning via heat dissipation, algorithms on others, and a bunch of stuff for the first time here today. So yeah, it's gonna be a treat. Cute. Okay, so how does a thermodynamic computer work? Well, right now what I'm going to talk about is a passive thermodynamic computer, which is essentially a computer GG function. So what you want is actually a full functional approximator of energies, right? Like how it's pretty simple, but essentially you can have parameterized probability distributions that you let nature compute for you very energy efficiently, right? And so that's more or less how our hardware works, right? So here's an analogy. What would that look like for a mechanical system? You know, if you have a bunch of masses and springs, right? Springs and masses are parameters. You could tune those parameters and you could put them in a box of bouncy balls undergoing Brownian motion. And eventually the system will equilibrate and you could observe it. And at equilibrium, you're going to get samples from this exponential distribution. Pick up the firmware layer. Well, slightly above just the pure hardware, we want to train the system, right? So and everything I'm talking about has a crap ton of patents. So if anybody's tempted, bring it on. Yeah. So basically, you could tune the parameters according to a gradient-based algorithm, and you could train the system to learn any distribution you want. Here's a basic training of a distribution here. That's basically how it works at the firmware layer. Essentially, there's some people that claim to be thermodynamic computers, but only offer passive thermodynamic computers for Gaussians. We think that That's not universal, right? You can't achieve universality. You can't represent arbitrary probability distributions. And it's not that interesting from a physics-based computing standpoint. It's much better to map much more of the algorithm into the physics. And so what we do is basically full neural EBMs in hardware, and we can learn general distributions.
Fucking beautiful.
What can you do with EBMs? Well, actually, you're probably familiar with DALL-E or Midjourney or ChatGPT video or whatever. They're all diffusion models. So diffusion models, what they do is they take data and they noise them progressively over maybe 1,000 steps, and then they use learned Gaussians to go backwards to learn a variational denoising map, right? And you have thousands and thousands of steps. That's what takes so long for your diffusion model to run. If you ever use Midjourney, it takes minutes, right? So if you shortcut, if you smash down these Gaussians and these trajectories into more expressive models like EBMs, you can get away with 100 times less steps. So there's a paper, Denoising Recovery Likelihood with EBMs. It's a paper by Google a couple years ago. But you could do basically diffusion models with a chain of denoising EBMs, right? So this machine can do basically everything like diffusion models can do, but better. So that's pretty great. That's a lot of applications. The next slide is very fresh, just specially cooked for today. It's very preliminary, so yeah, wait for the paper. So yeah, disclaimer, wait for the paper. But we thought, okay, can you do a whole transformers physics? Can you crack that? And we've invented that. We figured out how to do that, how to train and do inference on transformers. And turns out if you're going to build it in a substrate that I'm going to show, this is for superconductors. You can make servers that are more or less parallel. You can achieve like ridiculous amount of tokens per watt second, right? Tokens per joule, right? So tokens per second divided by watts. It's 100 million times more energy efficient, basically.
Hold on. There's a grammatical mistake. Superconductors can achieve unparalleled. Okay, kind of mistake, I guess. I don't know.
Which, again, ballpark of the brain. Again, this is not a machine we've built. It's in simulations, so it's a projection. I'll show you in a second the machine we've actually built. But this is extrapolated from the data we got there and are as accurate as we could simulations. In terms of speed, it's about 1,000 to 10,000 times faster in GPU for inference of deterministic neural networks. So for sampling of Monte Carlo, it's about 1 million to 10 million times faster if the problem is native. Because again, basically you're replacing Monte Carlo steps that you would code at 1,000 hertz with electron fluctuations that happen at 80 gigahertz. So this is our superconducting lab. This is as microscopic as you can make a thermodynamic computer. Anybody claiming they can do a breadboard in their garage that's a thermodynamic computer, injected synthetic noise, and it's a LARP. So we had to go to great lengths to make as macroscopic of a prototype as we could. This chip is about as big as your thumbnail, but the features are visible. And we have a whole cryogenic lab to fabricate and test these devices. These use superconducting Josephson junctions to create, again, general energy functions over the continuum. And there's a whole movie online, you can check it out. We showed our fab and lab and how we've manufactured these devices. But essentially, were you to scale a massive superconducting supercomputer, you can have the most energy efficient transformer you can build. Mm-hmm. And so that's probably, for us, this was a stepping stone. This was like our breadboard prototype. So this fab is in Sherbrooke. On the left is our chip. So, we have 25 patents and counting on this paradigm. So come talk to us if you're interested in scaling this. So that's our first thermodynamic computer. This is a programmable energy-based model device. I'm announcing today that we're going to be open sourcing the blueprint for the software and hardware. So how we could do all sorts of algorithms and how we can map algorithms onto superconducting by end of year 2024. So check out the white paper when it comes out. Stay tuned on Twitter and socials and so on. So why are we burning our boats? Well, the timelines are accelerating, and essentially we cracked how to do thermodynamic computing in silicon, which is obviously important for large-scale manufacturability. In terms of energy efficiency and speed you can achieve if you have a hardware native energy-based model, it's pretty significant. So those are our orders of magnitude. Our goal is to pack more intelligence per watt and per nanosecond than any other substrate. And so we're partnering with customers where that matters a lot, and they're ready to put some dollar signs behind that. So those are simulations. We're taping out by end of year, and testing begins early 2025. So we're looking for partners who want to try the very first chips and partner with us on the software and hardware. But yeah, it's us. We're Extropic. We're the real pioneers of thermodynamic computing. And I'll be taking questions during the break. Thanks.
Okay, cool. Pretty cool. I see. If a man does not have reason, if a man only tries to live for himself, oof, he's gonna get fucked. He's damn motherfucker. I see now. I fucking see now. Oh, I see now. Nah, nobody thought to stick. Oh my god, bro. What the fuck, bro? Shut the fuck up, man. I hate thread guys. Whatever, bro. No, this would be so cool. This is a powerful image. Shut the fuck up, bitch.
You want a fucking war? Then you'll get one! Say hello to my little friend!
Man, you gotta save Willie, huh? Are you crazy? That's suicide.
If I don't try, I won't be able to live with myself. You know what I'm saying? Like, I may be a loser, but I'm not a fucking coward.
What? Wait, Lino, wait! Fucking Willie.
Get the fuck out of here, pendejo! Wrong way! Run, you little punk! I got him!
Man of menace, huh? Bro, what the fuck, bro? Where do you work, Matthew Kenny? Okay, sure. Interesting. Thought token 2, thought token 1, base text. It allow all thoughts tokens to pay attention to themselves when preceding thought tokens within the same thought. And all the preceding text, we can generate continuations of all the thoughts in parallel. Each inference call is used to generate one additional thought token. Okay, I love this. Hold on, bro. You gotta study. You gotta figure out a way to get out of this slop. Get it now. I low-key get it, bro. Disconnect, please. Viado Tube. Where is Viado Tube? It's right here. Okay, cool. Parallel entrance. That's fine. This is all good. Okay. Isn't Mark Robber married, bro? That's crazy, bro. Hold on. Let's see. Mark Robber divorce. Okay. Oh, dude. Interesting. This is ChatGPT, bro. This is ChatGPT, bro. That's crazy. This motherfucker just. Bro, this is crazy. Oh, I get it. Mark Robber is this guy. Okay. Pretty cool. Cool.
Tell you, it was perfect. Perfect. Everything, down to the last.
Whatever, bro. What is Eva's power here? Too late. Cool. What is this fucking thing, bro? Ew. I see now. How was this release in any way launching flammable garbage into space? This exceeded my expectation, invited near universal praise, and had one model and one open model card, and most importantly pissed Gary Marcus off. What more could they have done? Who's Gary Marcus? Crazy. Let's see Aiden Clark. Sure, I'm gonna follow Aiden Clark. I gotta figure out Aiden Clark, bro. Bro, this is an insane. Motherfucker. Why you ain't got nothing, bro? Scholars. Oh, I see now. I see, interesting. I love this. It's a pretty cool website, honestly. Let's look at a scholar. Your no cited, sure. 2022, sure. Advances in neural information processing system, NeurIPS. Okay. Crazy, bro. Aiden Clark. Okay, hold on. Okay, anyways, cool. I get it. Aiden Clark. Cool. Shengxia Zhao. What is this? Let's see this dude's website too, please. Sure, this just doesn't work. That's how you know this dude's gonna be cool. I like this. I kinda like this. Okay, Gemini Advance is really good, it seems. Gemini Advance is like really good. Okay, cool.
iPhone 4. I've got an article here. I'll pull it up on the previous model so you can see the difference. Take a look at how sharp the headline is. Big, bold typography reading Sonic and Shadow have a big fuck. For those in the back who might not see the screen, here's what the article says.
Yeah, OmniVision is pretty good. Cloud Opus Vision is so bad. That's crazy, bro. I like the O1 preview is so far ahead.
Sonic.
Crazy, bro.
Ковбои скачут там на лошадях, то на быках такие. И каньоны.
У них большой долг, госдолг. Они любят фастфуд, тот же, что и мы. Картошку фри, бургеры. Депрессивные дети.
Наверное, стереотип, что они не умеют готовить.
И не готовят.
И не готовят.
Стереотип, что они ходят в пижамах прямо на улице, не чешутся, не расчесываются.
Да, что они, не любят ухаживать за собой же.
За то, что американцы толстые, и они еще тупые. Географию очень плохо знают. Джордж Буш путался, где там Ирак и Иран.
Ну что они мнят себя там еще, типа, как будто бы они такие, типа, короли мира. Потому что женщины за собой там не ухаживают, могут там выйти в чем попало в магазин. Как-то так.
Так неглубокие, поверхностные.
Малообразованные, такое узко мыслящие, скажем так.
Не следят за своим здоровьем.
denominator of a fraction 7 is less than 3 times its numerator. Sure. Denominator of fraction 7. Fraction is 7 less than 3 times its numerator. So numerator is n, denominator is 3n minus 7. The fraction is equal to 2 by 5. So n is 2. So 3 2s. Bro, what? Can't be there. Can't be there. So equals 2 by 5. So it's just gonna be like 5x equals 6x minus 14. X equals 4. Bro. To make parsing individual steps easier, we train generator to produce solutions in a new line delimited by step-by-step format, especially. Okay, fine. Okay. Sure. What the fuck? Interesting. Interesting. Gotta search this one real quick. Alibaba coin. Okay, cool.